Okay, so we'll be taking a problem on flexural strength. So we have a sample problem here. It says determine the flexural strength of concrete using the third point loading method. Given the following: span of beam is 450 millimeters, length, breadth, and depth of the beam are 500 millimeters by 150 millimeters by 150 millimeters respectively. Flexural load is 19 kilonewton. Okay, so for the given problem, remember, whenever we are given a problem, the first thing we do is to write down our parameters. So we have the span L to the 450 millimeters, which is 0.45 meters. We have our length, breadth, depth, and flexural load. So let me give us a graphical description of what this question looks like. So the question says, using the 3-point method, determine the flexural strength. So for the 3-point method, we are assuming that we have a beam, okay, and then we have two supports, simply supported, and the supports are acting 25 millimeters from the end of the beam. Okay, so this is 25 millimeters. So from the end of the beam to the support is 25 millimeters. And then this is considered as our span L, which in this question is given as 450 millimeters. And then we have two loads using the 3-point method. Okay, this is given as P and this is given as P. So we can see that our span L is what? 450 meters. And the total length is 500 millimeters, which if we have 25 millimeters from this end and 25 millimeters from this end, having the total length to be 500 millimeters. Okay, where we have the breadth and the depth. So the flexural strength is given as 3PL all over BD squared, where P is the flexural load, L is the length, the span, B is the breadth, and D is the depth. So we have the flexural strength to be 3 times the flexural load, 19 kilonewton, times our span, 0.45 meters, all over our breadth, 0.15 meters, times the square of our depth, 0.15 meters square. Okay, so we can see from here, this meter takes out this meter. So our flexural strength is given as 3 times 19 kilonewton times 0.45 all over 0.15 times 0.15 meter square. So it's going to be given in kilonewton per meter square. So we have our flexural strength to be what? (7,600) kilonewton per meter square. Okay, so that's how to determine our flexural strength when we are given the parameters, the dimensions of our beam.